Now, one of the term of this particular sequence, 72, 70, 68, 66, that's 40. We need to obtain that particular term. Now, let's begin. First, we need to check whether if this sequence is in an arithmetic progression or not. So here we have the first term, which is 72. The second term is 70. The third term is 68. And the fourth term is 66. And this kind of on continuing. So here, let's label this as A1. This is going to be our second term, A2. Then 68 will be our third term, A3. And 66 will be our fourth term, A4. So if we do A2 minus A1, so that will be 70 minus 72. That's going to be negative 2. A3 minus A2, that's going to be 68 minus 70, which is negative 2. And A4 minus A3, that's going to be 66 minus 68, giving us a value of negative 2. And we see that we have a common difference of negative 2. So our given sequence is in AB. So we have D value as negative 2. Now, let's try to find out the nth term. The nth term is given by A1, the first term, plus n minus 1 times the common difference D. So here A1, our first term is 72 plus n minus 1 multiplied to the common difference, which is negative 2. That's going to give us 72. So we'll multiply negative 2 to n minus 1. So we have negative 2n plus 2, which will be equals to 74 minus 2n. So this is going to be our nth term. Now it's given here that one of the term is 40. But we don't know which particular term is. So let's say that our nth term, this value is equals to 40. So that we will replace this value in place of an. So we'll have 40 equals to 74 minus 2n, which is going to give us 2n equals to 74 minus 40. So that will be 34, which means the n value is 17 or 17. So that means the 70th term of this particular sequence has a value of 40. Let's move on to the next problem. Problem number 2. So here, one of the term of this particular sequence is 124. We need to obtain the particular term. So which term is giving us the value 124. So let's look at this problem. So first we will check whether if it is an AP or not. So here we will consider our first term A1 to be 4. Our second term A2 is 9. Our third term A3, that's 14. And our fourth term is 19. So clearly A2 minus A1, this is going to be equals to 9 minus 4, that's 5. We see that this also equals to the third term minus the second term, which is also equals to the fourth term minus the third term. So we have a common difference. So this is going to be the value of D, the common difference. Now we know that the nth term, an, that's given by a1 plus n minus 1 times the common difference. And this is the first term, which has a value of 4 plus n minus 1 times the common difference of 5. So we have 4 plus 5n minus 5, or simply 5n minus 1. So this is the nth term. Now it's given here that one of the term is 124. So let's suppose that the nth term is actually 124. So that means 124 must be equals to 5n minus 1, or simply 5n equals 125. So n is equals to 25. This means that the 25th term of this particular arithmetic progression is 124. Let's move on to the next problem. So let's find out the term whose value is 248. So first thing first, let's find out the common difference. So to find out the common difference, we will subtract the second term from the first term. So that will be 8 minus 3. This is going to be equals to 5. Fine. Similarly, we can find out a3 minus a2. So that will be 13 minus 8, which is also equals to 5. We have a4 minus a3. So that's 18 minus 13, which also has the value of 5. So that means our common difference is D equals to 5. And this particular sequence is an AP. Now, since it's an AP, the nth term is given by a1 plus n minus 1 times the common difference D. So the first term is 3 plus n minus 1 times the common difference 5. So we have 3 plus 5n minus 5, or simply 5n minus 2. This is the nth term. Now, let's say the nth term, an, that's given by 248. That means 248 must be equals to 5n minus 2, or simply 5n is equals to 250, or simply n equals to 250 over 5, so that's 50. So that means the 50th term of the arithmetic progression, that's going to be equals to 248. We can actually verify this. So let's also verify. So A50, if we use this particular formula, then this will be our first term, which is 3 plus n minus 1. That means 50 minus 1 times the common difference, 5. That means we have 3 plus 49 times 5, which is going to give us the value 248. Let's move on to the next problem. Now, here we have our first term, so that's 84. Our second term is 80, and our third term is 76. So here you can quickly find out the common difference. So this is going to be an EP. So we'll just consider the second term, and from it we're going to subtract the first term. This is going to have the value 80 minus 84, which is negative 4. Now, the nth term of the sequence is going to be given by the first term plus n minus 1 times the common difference, d. Our first term is 84, so this will get added to n minus 1 times the common difference, negative 4. So we have 84 minus 4n plus 4, or simply 88 minus 4n. So this is the nth term. Now, we have to show that one of the term has a value of 0. So let's say that the nth term has a value of 0. That will mean, if we consider an to be equals to 0, this would simply mean that 88 minus 4n will be equals to 0, which would mean that we have 4n equals to 88. Solving for n, we have n equals to 22. So that means the 22nd term of the given sequence is going to have a value of 0. Let's move on to the next problem. So here we have a sequence for 19, 14, and one of the term has a value of 254. We need to find out the particular term. So here the common difference is going to be equals to, so we'll consider the second term, which is 9, and from it we will subtract the first term, that's 4, so this will be 5. That means our nth term will be given by the first term a1 plus n minus 1 times the common difference d. Our first term is 4, so we have 4 plus n minus 1 multiplied to be the common difference 5. So we have 4 plus 5n minus 5, so this will be equals to 5n minus 1. So this is the nth term. So it's given that one of the term is 254. So all we have to do is we'll suppose that our nth term is 254, such that 5n minus 1 is equals to 254. Or we have 5n equals to 255. Solving for n, we have 51. So that means the 51st term of this arithmetic progression has a value of 254.